let's do this. So this is another open-ended lecture. We're going to go through stuff. Okay. I got my cheat sheet here because I knew my mind would be fried by 3 116 lectures. So we're going to finish the deployment that we started last time. We're going to finish that up and talk about the rest of the things I wanted to talk about. And damn it, Rin. Is nuts even a valid top-level domain? So we're going to finish up that deployment. We're going to do some data structure stuff for WebSockets, some things that, just things that'll help with Homework 3. And then I want to do some testing with HTTP. I'm seeing quite a few office hour questions that I realize I haven't quite prepared you for. So I want to show you how to set up some more testing in HTTP. And just like I showed you how to set up the test for the computing the accept in a WebSocket handshake. But there are a lot of issues, even when there's that test case and you're computing the accept perfectly fine, everything's great. Once you get the HTTP request for the handshake, things go wrong. And unfortunately, the browser really doesn't tell you anything. If something goes wrong with the WebSocket handshake, if anything at all goes wrong, usually the accept being the wrong value, it just says, nah. It just doesn't tell you anything. It'll say finished on the request, the WebSocket request. Then if you go into your browser console, it'll say WebSocket connection failed. You get no hints, nothing. So being able to test that, I want to get into how to do that a little better. And we should be able to get through all 3 of these. I'm confident we can. And then Friday will be all about reports. I'll do a demo of going through a report. I usually pick on Socket.io in those, so maybe I'll do something different just because I'm sick of looking at that one. And deploying being the first thing that we're doing here, I do need a domain name. I'm not using RINs. They're not even in the class. They're graduated and on to bigger and better things. But if anybody has a domain name, we're going to buy one today and deploy at that domain name. So let me know what you want. So where we were was, yeah, and you're all comedians. With UB rating songs, I saw the very clearly 312 students adding songs in there. I had to remove them all. Thanks for making me do extra stuff. All the clear like injection attempts, which I can't be mad at. I'm proud of you for trying. But I went through and deleted all those songs because it's going to mess up. 116 students are using that data for their testing and stuff. I don't want them to have all that garbage in there. So we had, now I forgot what server I used for this, Docker PS 10 days ago, so not this one. We used my other one. So let's get into our server. We can look at our app. It should still be running. And 6 hours, 47 hours ago, that's going to be the one. So I deployed the Steal My Token app. We deployed it on 8.365. We went to the browser. Oh, not that browser. We went to the browser. We went to my IP address. :8.365, and we got to this app. So we can access it. We are live to the world. What we did so far, I shouldn't say all we did, is we got a DigitalOcean droplet. You can use any way to deploy your servers, anything that'll give you a server with a static IP address. Hell, you could actually host these from your house if you want, as long as your IP address is pretty stable. Like I always thought ISPs changed your IP address like constantly. Like your IP address is constantly changing when you're on campus. But with my home internet and a few other places, like my parents' house and stuff, the IP address hasn't changed in years. Like it is pretty static. It's not actually static. If you want an actual static IP address, which means your IP address will never change, Verizon Fios at least wants a ton of my money, and I have to upgrade to a business account and everything. It's a pain. But as it turns out, they just don't change my IP address that much. So if you want to deploy just from your house, that's an option, as long as your IP address is pretty stable. There are also other options. There's no IP. Some of you have used this, I believe, which is dynamic DNS, and their website doesn't want to load. So it's a free service to get a, if you have a dynamic IP address, what you do is install software on your server or on your desktop at home. You can host a website right from your house. Install it on your desktop from home, and you notice your ISP is changing your IP address every few days or every few hours or whatever. You install some software on that machine, which is going to ping your no IP. And there are other services to do this one. This is just the one that I'm familiar with. That'll constantly ping their server and say, hey, this is my IP. Hey, this is my IP. Hey, this is my IP. And then if your IP ever changes, it'll update your DNS record. And then you'll have a no IP domain name. You'll get a subdomain. They'll give you a subdomain that's going to be yours. And then they'll update their routing tables to get requests for that subdomain and then forward them to your IP address at your house. So there are solutions even if you have a dynamic IP address. I have a static IP address because I paid DigitalOcean to give me one and a whole server with this IP address, which will be mine forever until I stop paying them. And then I deployed my app using Docker and then connected on that IP and that port to be able to connect to my site. So we are live. We're live on the internet, and you can type in this IP and port and access this site right now. Question?
How much does DigitalOcean cost?
So how much for DigitalOcean? $5, I believe. One of these I'm paying more just because I wanted some more horsepower on it. But if I want to create a new droplet, so one, you get your GitHub education pack, so you can get a certain amount of DigitalOcean credit for free. You shouldn't have to pay anything just to start out, just to build your first app. And you have all kinds of options where you want your data to be located. If I want it to be located in Bangalore, I can choose East Coast, West Coast. Also, I want Ubuntu. I can choose my Ubuntu version. Basic sounds fine. And then you'll get to your cost. And they hide it a little, but they got this little arrow. They'll give you all the options. Click this arrow, and you'll get the cheapest option. Looks like down to $4 a month. I think it was $5 last time I created a droplet. And that's plenty of power for anything that you're building in this course or anything that you're prototyping or hackathon projects. $4 a month is going to give you enough to host all of that. I believe I'm paying the minimum on the one that's hosting all my course websites, and then the ones where I deploy different things like the Towers game that takes up a little more CPU and RAM. It's a little more intensive. I think that one I went up to $20. The pricing changed since the last time I did this. But $4 a month is your cheapest option if you are paying. So when you do run out of free credit from GitHub. $48 a month. So something's selected here. What do I have select? Oh, I didn't click on 4. I'm like, why? What are they sneaking in here? Yeah, I didn't click on the 4 per month. Yeah, so $4 a month is your cheapest droplet option. Again, not sponsored. DigitalOcean, if you're listening, I'll take some money. How do I get back to where I was? Goodness, I feel so lost. Droplets, that's where I want to be. And then I get my IP address. So I pay for 2 droplets, so like $25 a month I'm paying for these. Actually, I don't remember how I have this set up. They're both pretty small. Maybe I never did pay for a bigger droplet. But anyway, and then I logged into that. I SSH'd into my droplet. I installed Docker. I installed Nginx, which we're not even using yet. I installed Nginx. And then I ran my app on Docker using Docker Compose, and whatever local port I had in my Docker Compose file, I have my local port. Broken pipe. It kicked out of my server. So whatever local port I used, which was 365 in this case, and then inside my container, for whatever reason, I don't know why I set it up like this, I'm using port 3012 inside my container and mapping it to that port inside. Whatever public port, whatever local port I'm using, that's the port on this host, on this server that's going to be listening for connections to my app. So that's the one I'm going to connect to from the outside world. 365 is going to be that port. Kind of walked into that one. Did I really? Like, I didn't set it up. Nobody has a real domain name? All right, so that's fine and all, but we want an actual domain name. I'm not going to say, hey, come visit my site. It's at 159.89.179.140:8365. I'm not going to do that. And port 80 and 443 are already being used on my server. They're being listened to by Nginx, or else we could change Docker Compose to listen on port 80, and then that would be fine. I would get connections on port 80 going right to my app, so I could just say, here's my IP address and skip the port part of it. Gets us a little closer, but really we want... Can you tell my feet are getting sore? Just looking up insoles. We can get some domain name action in here is what we actually want. Google's taking forever to load too. This has got to be the Wi-Fi. Just going slow. And we can look at all my domains, and we can get a new one. All right, Rin, I'll try. Even if it did exist, yeah, it's not a top-level domain. At least make your... That's not what the suggestion says. I'm just going with what was suggested. It doesn't exist. At least make your jokes make sense. That's what with the music ratings app, all the fake things that are added. At least make the Spotify ID a valid song. It was so low effort, some of the things that I saw, but at least make it a funny song. So when I click on it, like, what the crap is this? And I click on it, it's some dumb song or whatever. But anyway, we need a domain name still. I'll wait. Oh, I can't even type. And that is available. God damn it. Gotta get something, or else I'm gonna think of something really dumb. There's no way that's available.
You're allowed to do it that way without like any verification.
Unavailable. A what?
Yeah, like you're allowed to do .org without any verification.
Oh, yeah. Yeah, absolutely.
What about that though?
I don't think I can do... I think government keeps that locked down.
Yeah.
They would have to, because we actually get to trust that. Like, if it's a .gov, like, we can trust that to be from the government.
Yeah.
Not shady.store. $50 a year. Oh, all right, I'm not spending $50 though. That's... I was game for that one, but not shady.us, maybe. Is Discord actually available? Discord.com with 2 I's. It's already registered. Again, .us, thiswire.com, thisrope. I'mUncreative.com. I like that one. Yay or nay? I'm good with that one. I'mUncreative.com. Okay. Auto renew off. I always got to make sure I remember that one. I'll buy it for 1 year so that it's gone. And then I've had it before where I want to reuse a domain the next year. I don't set auto renew, and then the lectures line up exactly. This actually just happened with UB rating songs. I didn't set auto renew, and then exactly 1 year later, I'm doing that again in lecture, and I wanted to reuse the domain. And then I deployed my music ratings app, and then the domain expired, and it went down right away. Luckily, it was before I released the homework, but one of my TAs caught it and said, that's gone already. Shit, I didn't pay $12. And then I'll buy it. You can have the last four of my credit card and my home address and phone number and private email. Well, I dox myself every semester. It's just gotten used to doxing myself. So now we have this domain name. This domain name belongs to us. But I bought my domain name, and like anything, there's a ton of different ways that you can purchase domain names through Google or any other service. They're all going to talk to the same entity, which I always forget what it is, that actually controls the domain name registration. They'll talk to that entity for us, but we can't talk to them directly. We have to, Google has to get their cut, or whoever you're paying. I do like Google for this. I don't like Google for a lot of things, but Google manages domain names really well. A lot of services sell domain name registration and hosting services, and if you buy a domain name from them, they do what they can to lock down your domain name into their service, so you also pay for their hosting service. I'm paying DigitalOcean for my hosting, so I want a domain name, a way to register domain names that's just going to let me use DigitalOcean without trying to sell me some extra crap. And for what it's worth, Google doesn't try to sell me extra crap. Even though they do have their own hosting service, they don't try to push it on me whenever I buy a domain name. But other services, I don't want to attribute intent or anything, but they do seem to make it difficult to use that domain on another service that's not theirs. And I've got locked down. I used GoDaddy before by mistake because, I don't know, it's the one I knew because they had a bunch of commercials way back in the day. And they really wanted to lock down my domain names and make me use their hosting service and give them my money and only them my money. And there's a process. I finally got my domains transferred, but it was a hassle. With Google, I click DNS. It might still be in my clipboard. I paste my IP address, and I'm going to create an A record, and I'm going to save. Oops. Oh, this is the host name, which I believe can be anything. I'll make it match the domain name. I forgot how to do this. I'm going to create a record, and what that says is, oh, damn it, I did do it wrong. Oh, my goodness. This is blank. I thought that's what it is. You do an A record for your IP address. And what this says is, hey, hey, Google, update the DNS records so whenever a request comes for this domain name, fire that off to my IP address, and I'll take it from there. So now when I go to I'mUncreative.com, probably nothing's going to happen. Actually it did. So it takes a while. It generally takes a while, and everything will say 24 to 48 hours for DNS to propagate. So it takes a while to send that record, this domain name registration that I just did a few minutes ago, and updating the record to have it point to my IP address. The whole internet, all the DNS servers have to get that information. So Google goes and tells everybody, hey, this domain name, can you point that to this IP address? And then all the DNS servers update their records, and we can go there. They say that takes a while, but these days, in my experience, it's like that. It just took no time at all. I'm getting a message from Nginx, so I'm pretty confident that that's coming from my server. If I go to, what browser am I in? If I go to Developer Tools, if I go to the Developer Tools, the Network tab, refresh, it is already pointing to my IP address. So the DNS already propagated. It's already good. We're good to go. So now I want to update my Nginx, because Nginx is getting that request, and it doesn't know what to do with it, because I haven't told it what to do with it. And my broken pipe again. Why do I keep getting kicked out of my own server? etc.nginx. So now we want to update our Nginx records. I have all my configuration here, and I'm going to copy one of these just so I have a starting place. Let's do this one. I'm uncreative.com. Pico, I'm uncreative.com. Uncreative.com. Okay, and I want to get rid of most of this stuff. Let's do it this way. The lag. So what I want to tell Nginx is whenever you get a request for this domain name, for imuncreative.com, then run this configuration on it. And for that, I want to forward it to localhost port 8365, so it goes to the right place. And I'm going to get rid of all this other stuff. Get this out of here. Get this out of here. Get this up here. And get this out of here. So this is what I want to set. So I'm saying if you get a request for this domain name on port 80, forward it to my local port 8365 where my app is running, where Docker Compose is going to forward that request to my app running inside my container. Use HTTP version 1.1, and then forward these two headers, this upgrade and connection. These I don't need for this app right here, but if you're using WebSockets, you need these two lines here because Nginx will not forward your upgrade and connection headers by default. So you have to explicitly say, hey, if I'm getting this upgrade request for WebSockets, make sure I get those headers. I really want those headers. And then I'm going to save this. And I'm going to reload Nginx. And that's it. So now imuncreative.com is pointing to this site. It's pointing to my server. Nginx gets that request. It's listening on 80 and 443, and then it forwards that to local port 8365, which goes to Docker Compose, which goes into forwards that to the container that's actually running my app on port 8012. My app does its thing and sends it back through that whole chain. So a decent number of moving pieces, but I don't think it's overly complicated. I don't know. It is a bit, but. And then finally, I keep saying ports 80 and 443, but we're only using port 80. That's the default port for HTTP. This is something we'll talk about a bit later, and I'll probably do this part of the demo again later on. I might do the whole demo again once we have more to talk about with it. Nginx, I'm going to go to something called certbot, which is going to give me a certificate. I'm going to choose Nginx. I think I'm using Ubuntu 20. I don't remember. I think it's the same command anyway. And it's going to have all kinds of instructions for me to install certbot, to install this script that's going to do all this stuff for me. I already have it set up. It's already installed, so I'm just going to go to the last part of this, which I, for some reason, I always forget. Run certbot on Nginx. This is how simple this is to get a certificate. I'm going to run this. It's going to say, whoa, looks like you got a lot of domains here. Which one are you talking about? Which one do you want me to generate a cert for? And I'm going to look for the right one. I'm uncreative.com 6. And what it's doing is verifying that I do control this domain name. So signing a cert, this is what we're doing to get encryption set up, to get HTTPS on port 443. And what the script was doing was generating random values, editing my Nginx configuration and generating random values, and then having its server access that domain name requesting those random values. And if it's able to get those random values, it verifies that me running on in this terminal window, I do actually control that domain name. And then it verifies, okay, it looks like you do control this domain name, so I'm comfortable signing a certificate for you and issuing that certificate. And it's going to ask me if I want to redirect or not. I want to redirect. What that means is when I get a request on port 80 with HTTP, it's going to automatically redirect that to HTTPS on 443. So I'm not going to let anybody access my site without encryption. And then it's done. If I go back into my configuration, I can see that certbot added quite a bit of configuration here, so I didn't have to do too much for my configuration. The rest is all certbot adding all of our HTTPS stuff and adding the redirect. If we get a request on port 80, redirect to HTTPS, and this is listening on port 443 with SSL enabled. So now I go to my site again. Let's get our window open, go to the network tab and hit refresh. We get our lock, we're secured. We get our first request with HTTP. We get our 301. Location is HTTPS, imuncreative.com. Second request is for HTTPS over port 443, and we get an encrypted connection so we can have encrypted communication with our HTTP requests and responses. Notice through all of that, what did I do with my code for my server? Zero, absolutely nothing. Everything in my app is still using HTTP, so the communication between Nginx, Docker Compose, and my app, all of that communication is unencrypted, but it's all within my server. Somebody would have to have access to my server to see that communication. And then Nginx is encrypting and then sending out to the real world. So anything that touches the internet is encrypted, whether it's a request or a response. We have a valid certificate, so the whole internet's happy. This is a secure site. Certificate's valid. I can see my Let's Encrypt certificate. Everything's good with that. And we have full encryption. I have a deployment on a domain name with encryption. We got it. That's everything for deployment. That's what we need. That's what we want. That's what we expect when we go to the internet. Like if you go to any site, especially the redirect stuff, if I try to go to a site without encryption, it's going to redirect me to use encryption. Pretty standard these days on the internet. Everything just gets redirected to HTTPS. And that's what I like to see. I want things to be encrypted. Okay, any questions on any of that? Team Pulse, producepong.com. How does the browser decrypt? With a symmetric key generated by a key exchange. That's a long answer that'll take like a lecture or two in homework 4 content to answer. But with a symmetric key. So actually I'll give you a brief explanation right now. So the way it works is I got the certificate, which is I have a public-private key pair for public key encryption for my server. So my server has a private key, it's keeping private, and a public key with a signed certificate that it can send out to everybody. So we can encrypt, people can encrypt and send messages to the server, but that's it. So how do we get encrypted messages sent to the client, because every client isn't going to have their public-private key pair for communication with the server and send their public key to the server. It's just not how it works. There would be issues with that. So what we do is actually negotiate a key exchange. The server and client negotiate on a symmetric key, which is used just for that connection, which is used for both encryption and decryption. And it's negotiated in a way where both client and server have the private key, but anybody observing the key exchange can't gain any information from it. They can't know what the symmetric key is. And then they both use the symmetric key to both encrypt and decrypt both messages from client to server and server to client. So that's how we do encryption on the internet. The very brief explanation of how we do encryption on the internet. For the longer explanation, we have when I want to see when we do get to that. I thought I fixed this link. Oops. We'll talk about it here and here. So these two lectures, we'll talk about all the details of that. But it's going to take me an hour and 40 minutes. Okay, let's get on to the next thing. Data structures for WebSockets. So we finished this. Done. So let's talk about data structures for WebSockets. I mentioned this kind of briefly. I did a very brief demo at one point even, but I didn't talk too much about it. So let's take a look at this server and expand this to kind of pretend that it works with WebSockets, which we have part of it. This is, I believe, the last one that I showed in lecture, the last Python server that I showed. And we want to upgrade to a WebSocket connection, which would happen right here. And then we're going to do homework 3, which I'm just going to steal from myself. I did give you the code, right? Here it is. I'm going to steal this code from myself, so it's the exact code that we both agree on. We're going to do this to generate a username for this connection, for this user. So we have access to their connection through self, and we have their username, which we just generated for them. And then we want some data structure, which the question of where to define that might be different for each of you, how you want to set it up, and how your server is currently set up. I'm going to put it right here, WS connections as a dictionary. Python, why don't you like that? Oh, I'm not indented. I got confused by my comments. Let me indent my comments too then. And then I want to remember this connection. So what I want to do here is remember that this connection is associated with this username. So I'll go into my WebSocket connections. Really? And remember that this username is associated with this connection. And I have to do, so I'm trying to use it as a global variable. This is a class variable in Python, which is something you may or may not have seen before. I believe I mentioned it when I did this before, but this is a class variable in Python. So to create instance variables in Python, you would create a constructor, and then in the constructor do self dot and add your instance variables. If you do your variables like this, like you would expect if you're used to Java or Scala or C++ or anything else, Python had to be different with this one. If you declare your variable right here, it's a class variable, or in Java terms, it would be a static variable. Or in Scala terms, you've all taken 116 in Scala. In Scala terms, it would be in an object instead of in a class. It would be the same idea. So this is associated with the myTCP handler class, and we access it that way. So we access it through the class. So I'm going to add my element to the data structure here, and then enter my well true. Since this data structure is associated with the class, it will be visible to all connections. It's at a level higher. It's not a local variable in the handle class. It's at a higher level than that. You can make it package level or module level. You can put it anywhere where it's going to be shared across all connections will be fine. And then in here, let's just print WS. Oops, I just went over that whole thing. WS connections. Let's just print it out. So each time somebody connects, we're going to enter this well true and print out all the connections just to verify that we have things working. And then we can ignore all this stuff. And we're just going to send hello. Let's run this server. Oh my goodness, where am I? Terminal. Let's run this thing. We're going to do cd servers, Python 3 server 3. I believe I'm running it on port 8002 for some reason. Okay. I'm going to open up a tab. Localhost 8002. Hello. Oh, hello yourself. Localhost, 8002. Let's copy this. Let's go to Chrome. Do it here. Oh, hello. And let's check out our server and see what we got. So now each connection, this is going to be our first connection, which is sending multiple requests. That's probably for the fav icon, I would guess. I don't know, maybe some. But the first connection's making multiple requests. And then when we get the second connection, we have this data structure with both connections in there. And let's get to the third one, which... Oh, I know what happened. Yeah, I saw this before. It's weird that it does this. But both of these connections, I'm glad I opened up Chrome. Both of these connections are from Opera. It's reusing that port across different tabs, which doesn't fully make sense to me. Maybe it's because it's the same host and port that it's saying, you know what, let's reuse that. I feel like it shouldn't be doing that, though. But then when we get the second connection from Chrome, we have both connections here. So inside your loop, and of course this would be your WebSocket setup, you would do your WebSocket handshake. You would enter your well true. You would generate the username and then enter the well true. And then read WebSocket frames, parse this as a WebSocket frame, broadcast that to all connections. So when you get to the broadcast to all connections, thinking of the chat part of the homework, when you get a WebSocket frame, you do all your parsing, you do all your demask the payload and get the payload length and all that good stuff. Your job is to create a new WebSocket frame and broadcast that to all users. And the question is, well, how do I broadcast that to all users? If you have this data structure set up, we crashed apparently. You have this data structure set up that's shared across all connections. In each of these well-true loops that all your connections are in, they all have access to a shared data structure. And then whenever they need to broadcast, they're going to iterate over this data structure and get all of the connections and send over this connection and send over this connection. So if we do like for connection in my TCP, my TCP handler .ws connections, connection request send all my WebSocket frame. So you do something like that. Well, not exactly like this because I messed it up. Values. Now it's fine. And that's going to iterate over all of them. And for those of you working on AO3, which aren't very many of you yet, but if you're going to be working on AO3, this is where you would want the username associated with those connections. So before AO3, you can just store the connections in a list. That would be fine. But once we're getting to AO3 and we need these connections being negotiated between multiple pairs of clients, we need to know the usernames as well, so we can identify each client, so the peers can identify each other and send messages to each other without having the ambiguity of sending a request for a WebTC connection and server not knowing where that's supposed to go. If we remember the username, communicate those usernames to all the clients, then they can use those usernames to identify who they want to connect to. So we have a need to send all these usernames to the clients and also send them their own username. For their own username, I like right here. You've seen it last time I demoed some WebSocket stuff or some WebRTC stuff. You saw the WebSocket message, the UR message that I was sending, which kind of leaked a little bit of my solution, but I'm going to leak it right now anyway, is right when you make the connection, you have the username, you have their connection handy, create a WebSocket frame, and fire off their username. Say, hey, this is who you are. And just say that to them right away. And then when the connection is established and when they're ready to make a WebRTC connection and join the Zoom meeting, then you somehow get them the list of all the usernames and say, hey, here's everybody. Maybe you want to send connections to all these people. I always forget I think these are thread safe. How do I even find out in Python? I want to say Python dictionaries are thread safe, but I'm not 100% sure on that one. Python forces synchronization for everything. Cool. I'm going to trust that because that is what my intuition believes. And my server crashed for some reason. Not really concerned why. It's just a toy example. All right, any questions on that one? Okay, moving on to the next thing, which I want this gone. I have to switch servers. Is this one handy? Oh, yeah, this is where I was talking about that same thing before. Let's go all the way back to server 1. Yeah, this is fine. So we have the issue of debugging when we have a server running. So let's run a server. Python 3, server 2, server 1. Server 1. We're listening on port 8000, and the important thing I'm looking for is this right here, this line right here. So I'm getting the HTTP request. This might be a WebSocket frame, or in this case, a HTTP request, or an HTTP request for an upgrade to WebSockets are the relevant things for homework 3 right now. And I want to print out that request in bytes. I want to print out the bytes of that request. Then I'm going to go to my browser. What did I just say? 8,000? Send a request. And I'm going to grab the bytes of that request. So the B and then the quote, that's going to tell me this is the bytes of the request. I'm going to grab this whole friggin' thing and copy it. Now this has all kinds of headers. It has all the information that I want in my request. And I want to make a test case of this. Take all of this information, send this to some code that I have, and make sure it does the thing that it should do. So this is where it helps also to have, I'll be a little dangerous here. This is where it helps to have separate methods for things. If you have everything in your handle method, you're not going to be able to set up testing. You have to refactor a bit to set up your testing. So it helps to have separate methods. In my server, I like to have a request class. So I have a request class which which in the constructor will do the parsing. It'll take the bytes of a request and then parse those bytes and get it the way that I want it to be. So I did exactly what I did just now, but I did this obviously before. And I have a request that I just pasted into here. So I have a legit request. This one is actually, should be, oh no, it isn't. No, it's just header, just to get request. It's a request that I have, and I'm going to check to make sure that everything's being parsed properly. And I did the same thing for, I'm not going to open this one, but where did I do it right here? No, I didn't. That's the code for it. But you can do the same thing for like multi-part forms. Take a whole multi-part form request, plomp it into your test case, and then make sure you're extracting the right information. Here I'm going to make sure that I get the right path. So I'm creating an object, and that object is going to have instance variables with all the information that I expect. I'm going to check to make sure the path, method, etc. are right. And I'm just checking one header here. I have my code that's going to parse the headers and make sure that I get the right header value for the host. I could check all of these, of course. I got lazy making this test case. I think I just made it during lecture. I don't know if this is the one I used during testing. I feel like I would have built more of it. But I can test if I am getting the whole request. Where this really comes in handy for the current homework is when let's see if we can do this real quick.